Hi everybody, you're watching the week 6 video for ALEC 341. I just realized I had not updated this to say spring 2018 and have the correct logo, but just know that this is for spring 2018 and we actually have a better looking logo for streaming science, right? Anyway, moving on. Week 6, what you need to do this week, you need to read chapter 1 of Science for All Americans. If you bought the book, awesome. If you didn't, it is free online. Go to the syllabus, find the link there that I have, and download the book. All right, so you're also watching this video. Great job. And then you have 2 assignments due this week by Tuesday, February 20th. That'll be your production timeline and interview questions that we'll talk about in class, and I'll also show you quickly in this video, and your online activity number 5, which is about chapter 1 of this book. So don't breeze through the book. Make sure you take the time to kind of look through it and get some basic understanding of what it's about. So why this book? Why are we doing this? Last week you dug into Project 2061 and AAAS and what it's all about. So this class is called Podcasting to Increase Science Literacy. So I can never lose focus, right? We're learning the skills and the tools and the things you need to be a podcaster, but we're also working on this whole understanding of what is science literacy and how do we use things like podcasting and video and photo essays and streaming science and electronic field trips to help engage in this phenomenon of science literacy and increasing people's understanding of science, scientists, science careers, and basic scientific concepts. So something I want you to think about as you go and work with your scientist for your podcast. It might be someone in the computing lab. It might be someone in the English department who's more of a social scientist. It might be all of these people in these different roles, but they are connected to science, whether that's through a social issue or a hard science, data science project they're doing. Typically, when we think of scientists, research shows we hold these stereotypes in our mind of what a professor is like, what a scientist is like, what someone who works in Washington, D.C., solving societal issues and doing experimentation. We have this stereotype in our mind that they're a white man. They have crazy hair, they wear glasses, they wear a lab coat, they kind of look like Albert Einstein, they are just kind of this madman type person that's mixing chemicals and they're trying to manipulate us and manipulate the things we're consuming and just run these mad experiments on society. But we know that is not the case. You're going to be interviewing a variety of people from a variety of backgrounds. They're going to be men, they're going to be women, they may not all be white. You want to help through your podcasts show sort of the human side of science and the human side of these stereotypes and that they don't all fit these stereotypes. And one of our big missions and goals for streaming science is to let people know in ag and the environment and across science and all these different disciplines, social science, these are real people that really are working on solutions to societal problems. So I hope that really comes out in your interviews and the questions that you're developing. Help us humanize these people and humanize these topics. In your profile papers, a lot of you profiled podcasts that you said really helped you understand complicated content, but you also felt a connection to the people you were listening to. They were talking about pretty complicated stuff, but they helped you learn how to apply it to your everyday life or just how to be more curious about the topic. So as a podcast host, when you meet with these different people in their different roles, be curious. Find ways to help them become more comfortable in speaking with you and become more conversational and help share the passion of what they're doing and what they're finding out. So don't just play into the stereotypes of scientists. Maybe even have discussions with your person you're interviewing. When you say things like big data, I think totally geeky stuff about you. I think that you use complicated tools and technology that are going to be too hard for me to understand. Help me understand how you became to be a big data scientist. What is that type of science? What does it mean? How does it impact our listeners' lives? Have some real conversations with them that help break down these stereotypes about scientists. So when we start to look at this book, chapter 1 is really dealing with the nature of science. So it's this big idea that Science is this huge, complicated thing, right? But it's really broken down into some of these areas. The methods of science, what is the scientific process that's being followed? What are the tools that are being used? The psychology of science has to do with how scientists think, how society thinks, how we make sense of the world, and then the history of science. We've come a long way. Science has changed a lot over time. It maybe was more basic in what it used to look at, and now it's more complicated. So to even think of data science as a science these days is totally new and totally something we never thought of before. The science of collecting all of these numbers and all of these information pieces about how we work and function and operate as a society is really sort of this new field that maybe wasn't even thought of in the history of all of science. And the idea that all of this is happening not in a vacuum, but it's happening throughout the world, across cultures, across disciplines, across environments, is also really important to tie this into the bigger picture of what we're doing. So another key thing to learn about out of this chapter is the science world view. Our scientists have a certain mindset that they're coming from, then that's sort of what they've been taught throughout their college classes. It's how they operate as scientists. It's how they view the world. They look at the world as it is something that we can make sense of. We can find ways to understand it. We look at phenomenon and we try and figure out what they are, how they're happening, why they're happening, and we apply the scientific mindset to try and make sense of it and figure it out. Science is subject to change. It's changing all the time. We're always coming up with new tools, new methods, new ways of understanding things. Our hypothesis and our results from a past study might be proven wrong by a new study. Science is also durable, right? So even though it's always changing and there's always these new things happening, it stands the test of time. We can apply it over and over and over to try and make sense of things. It can't explain every single question we have. We didn't even know how to use or apply big data until the recent years. So we weren't able to answer a lot of those questions in the past that now big data is helping us to figure out. So we don't have the answer for everything. We're trying to figure it out. That's why we're using and applying science. It's a process that explains and predicts. So a scientist is going to have a question. Why is X happening? Well, I predict that it's because of these variables that we need to look into. I'm going to explain it through this experiment that I'm going to apply that's going to happen. It's evidence-based, so we're trying to find facts and logic and reasons why variables are moving and changing and doing what they're doing. We're trying to figure out why is the world, the planet, having more warmer days now than it's ever had before. So weather is a predictor and connector to climate and vice versa, right? So that relationship there of climate and weather is something that we're trying to collect evidence about over time. We're looking at how weather is changing over time with different climate models and modeling, and that weather is explaining the change in climate over time. So they're using evidence and logic and processes to explain and predict things. It's also a little bit of an imagination built in. So scientists, even though they're pretty logical and straightforward people that are connecting processes and evidence, they also have to have an imagination. Why would they dream up that question in the first place? What was something they noticed about the environment or our water in a certain location, or our clothing we're wearing, or our technology we're using, or the decisions we're making as social and behavioral beings in the world? They have to have imagination for how they're viewing the world and trying to find, solutions to problems and how they're going to carry out a study. It's also a very imaginative process. Scientists really do try to avoid bias, or at least we expect or hope that they are. That's why they have a method for how they set up control studies and run a control versus manipulating variables, where they're trying to look at things from a very logical standpoint and not necessarily an emotional standpoint. But as we know, it's hard to take out emotion completely. I've interviewed scientists who are trying to find the cure to Alzheimer's because their father had Alzheimer's disease. So there is somewhat of an emotional connection to the work that they're doing, but they're trying to look at it in a methodical way that avoids bias or controls biases along the way. Science is not authoritarian. It's not something that is top down, that has one sort of ruler or one body in control that's telling us how it should work and how it should be done and how we should view it. It's a community. It's a group of people that are working within the science endeavor and enterprise, and they're trying to help one another, support one another, make sense of questions together. They have a strand of they're a scientist, they might have a postdoctoral scientist, they might have graduate researchers, they might have courses, they might collaborate across labs, across countries. It's very much a community of specialists and citizens. We're also seeing a movement for citizen science, where scientists are trying to make sense of a phenomenon, and they'll call on community members to help collect photos, to help collect temperature ranges, to help collect data about insects or their food, or understanding their behaviors, where they will actually contribute to a study and add data to it. So these are all really important things to understand about the science worldview that'll give you some insight into how to speak to your scientist and where they might be coming from, and why they might be how they are, and applying the things that they're applying to the research they're doing. The scientific enterprise, as we talked about a little bit just on that last slide, it's a very complex thing. It's complex at the international, national, local, regional, global level, individual level. It's a complex social activity. It's not just a person operating in a vacuum. It's lots of people looking into the scientific enterprise. Science is organized into disciplines. Even if you look at IANR and KASNR and how we are organized, we have departments. We have crop science, we have water science, we have horticulture, we have the social scientists, our ag education, communication, leadership people. We're organized into disciplines to help make sense of the different pieces of things that we are looking at when it comes to ag and the environment, but we also work together in teams. The National Science Foundation, the USDA, the National Institute of Health, all of these things call on us to work across our disciplines and in teams to solve larger global issues. The applied and hard scientists and bench scientists might be looking at things like genetics and the molecular level of things, and then the social scientists might be looking at why aren't consumers adopting GMOs? What are their attitudes and perceptions and behaviors about these issues? There's also this accepted ethical sort of code of conduct across science, and the boundaries are always being pushed on this, right? We hope that they're avoiding bias. We hope that they're using professional tools, and that they are not manipulating data, that they are honest and true in how they're analyzing data. We have the Institutional Review Board, IRB, that all of our studies have to be approved by. It's this idea that we're taking in funding that isn't manipulating or controlling the message or the how we conduct our research, but know a little bit about the ethical piece of science and how it's conducted as well. And then specialists and citizens, like we said, are becoming more and more involved in science. It's not just a controlled study all the time in a vacuum in a lab. It's also starting to incorporate and involve many more people in the scientific enterprise. Know about scientific inquiry. We talked about this a little bit in class. It used to be called the scientific method. Now it's scientific inquiry. It's how a scientist works. So through streaming science, when we create our podcasts and our videos and our electronic field trips, this is the piece that most teachers find the most valuable for introducing their students to scientists, how scientists work, and the nature of science. We know that scientists follow these steps. They ask a question, they have a hypothesis, they test the hypothesis, they make their observations, they analyze the results, they draw conclusions, and then they might hit final results. They might answer their question, but a lot of times you don't answer your question all the way, and you go back to the beginning and you run the study again, or you change something about the study. And then eventually you get it to a point where you do communicate the results to the public. And that's where we're here to do. We're here to help talk about this process with our scientists. What are they trying to find out? What data are they collecting? How are they analyzing it? What tools are they using? What do they hope that they're finding out? What do they hope that they can share with the public, and how they're going to impact people's lives with what they're doing? So work some of this into your interview conversation with your person. How are they doing their research? What do they love about it as well? Don't forget the emotional stuff. Why do they care about it? Why are they passionate about it? But use this to get through your more factual questions. And they're going to give you a long answer if you just say, tell me about your research. They're going to talk forever, and you're never going to get a word in edgewise. But if you break down your questions into, what is the hypothesis you have asked? What question are you trying to solve? What are your observations so far that you've noticed about this issue? Break down your discussion into these pieces so that you don't just get the really long answer back about the total description of their work. This will help you talk through their work. All right, your assignment, one of them this week, besides the online activity, you also need to do this, right? We'll start developing these in class, or talking through them at least, but then you need to submit them in this document. I want you to have 12 to 14 questions per podcast that you write out, and we can whittle these down further after you turn this in. But 12 to 14 for about a 30-minute podcast is probably pretty fair to give you enough material to work with and edit down. I want you to come up with factual, objective questions, but also subjective questions, and weave them together, right? So what is the flow of your podcast? What are you going to ask in the intro, body, conclusion? How are you going to weave the different types of questions together? How are you going to word these things to keep them conversational? So you'll do that for each podcast, come up with the 12 or so questions. And then I want you to start coming up with this production timeline here, a working title for your podcast. What is something, what's a catchy title or a straightforward title, something that you're kicking around in your mind about this person? It might have streaming science incorporated into it somehow, or big data. And then I want you to develop this timeline. I do this in all of my classes because I want you to learn, as a budding science communication professional, how to manage your time. So look at the syllabus. When are your final podcasts due according to the syllabus? And then backtrack from there. Estimate what weeks will you be spending on editing? What weeks will you be spending on interviewing? What weeks will you be spending on your pre-meeting and all of those things you need to do? And work all of that in to your timeline and make it reasonable, make it detailed somewhat too. You need this much time to edit the intro and the outro and add the music. You need this much time to edit the interview questions. Include a little bit of detail in all of that as well. And then kind of try and make yourself stick to that timeline this semester so that you know you're going to get your project done on time. So that'll be due on the 20th for 20 points. Follow the template and put your name on it and all that good stuff so I know whose it is, please. Here's a reminder again of what you need to do. Read chapter 1, you're watching the video, do the timeline and interview questions in online activity 5 by Tuesday the 20th. Hopefully my voice and cold issue is not super annoying in this video, but I do thank you for your time, and I hope you guys have a great week 6. I loved your podcast profile papers and all the work that you've been doing so far, and I hope you're enjoying this class, and I look forward to seeing how your final podcasts develop. All right, have a great week 6.